In the valence bond theory, we first have to count the number of valence electrons in the molecule. So we'll do that to arsenic pentaiodine. In arsenic, there are 5 valence electrons, 5, and in iodine, there is 7 in each one, so 7 times 5 is 35. So we'll get a total of 40 valence electrons. Next, we'll draw the Lewis structure of arsenic pentaiodine. This will help us determine what kind of molecular shape arsenic has with iodine. So I'll go ahead and draw the Lewis dot structure. We'll have arsenic in the center and the iodine around. I'll go ahead and fill in the electrons around the iodine. So that gives us 8 times 5, and that's 40, so we have the same number of valence electrons that we calculated up here. And from this structure we can tell that it's a trigonal bipyramidal due to the number of bonds it has with the iodine. So from the previous slide, we figured out that arsenic pentaiodine was a trigonal bipyramidal. Knowing this, we can now draw the Vesper diagram. So we'll have arsenic in the center, and that wedge means that it's pointing towards us, and these lines going smaller means that it's pointing away from us. Fill in the iodine. To show these 3 iodine are on the same plane, I will connect them and create a triangle. If you want to see it in a 3D model, I have one right here, and they are these 3 right here, all on the same plane. The angles of a trigonal bipyramidal are 120. It goes from here to here, and 90 degrees at the axial. Next, we'll do the box diagram for arsenic pentaiodine, which will determine if any of the electrons will get promoted and if any of them will get hybridized. So we'll start off in the ground state of arsenic, and we'll fill in the valence electrons, which are 5, and that gives us 5. Since we need 5 loner electrons so the 5 iodine can pair with them, we'll have to promote this guy down here into the 4d orbital. So we'll fill in all the electrons. All these electrons will now hybridize into the bonded state. So we'll need 5 slots. And since there's only from one S, it'll be S, 3 from P, and 1 from D. So it'll give us sp3d. We'll go ahead and fill in the electrons from there. And since we have 5 iodine, we're only going to use the electrons, the valence electrons, in the 5p orbital from iodine. And this one from each iodine will bond with each of the arsenic lone electrons. So all these are bonded. Now we can draw the contour diagram of this molecule. Again, we'll have arsenic in the center. And these lines will be our guidelines to drawing the bonds. Now I will attempt to label these as SP, 3D, and we can't forget the electrons that are within here. Just 2 in each one. And we'll draw the iodine bonding with arsenic. We have to draw it huge since it's one of the bigger molecules. I forgot these two right here. Go. And went to label these. All these are iodine. And they are sigma bonds. Yeah, you can't forget to label the iodine. They are 5p for each one. The angles are again, it's a 120, and since these are on the same plane, it's an equatorial 120. I almost didn't fit that. Then in here is the axial 90 degrees. So there you go. Here's a ugly diagram or contour diagram of arsenic pentaiodide. I'll bring a better representation of this with the 3D model. Hold on. So here you go. Here's a 3D model of the molecule. You can see the actual size of iodine compared to arsenic. And it's a lot better looking than the one I did. So that concludes our step-by-step on how to do the valence bond theory.